let's take a look at question 5. It says, suppose you have a general solution, and this is your differential equation with the initial condition that y at 0 is equal to 0 and y prime at 0 is equal to 1. Can we have a type of solution like this? First of all, let's check to see what do we have. It says if I plug in 0 for x, the y value must be equal to 0. It says 0 is equal to c1 plus c2 0 squared. Okay, it means that c1 is equal to 0. Then if we take the derivative of the solution, y prime is equal to c2 times 2 times x. Y prime at 0 is also 0, but it says, hey, y prime at 0 must be 1, which is impossible. There you go. Now let's go back to the theorem about the existence of a unique solution. The theorem says, let the coefficients a n x, a n minus 1x, and a sub 0x, and also g of x for the nth order linear differential equation a n x, the nth derivative of y plus a sub 0 x times y equals to g of x be a linear nth order differential equation. Then, with the condition that a sub n, which is the leading term, is not equal to 0, if x is equal to x sub 0 is any point in the interval that is defined for this differential equation, then definitely we can find a solution for the initial value problem, and it exists and it's unique if x is equal to x sub 0 is a point in the interval, then the initial value problem has a unique solution in that interval. So let's take a look at this question. It says you have x times the second derivative of y minus y prime equal to 0. Is any conditions for the theorem violated here? Here we are defining an initial value problem with these conditions. Note that here you have a sub 2, a sub 2x, the second derivative plus a sub 1x, the first derivative plus a sub 0x, y equals to 0. A sub 2x is just x, and a sub 1x is just negative 1, and a sub 0x is equal to 0. Note that if I take x sub 0 equal to 0, then a sub 2 is 0. A sub 2 at 0 is equal to 0.